Alright, we're back again and we're talking about our little friend, the bouncy light thing. The first step of our one-dimensional pong game, which looks like this and goes backwards and forwards. So if you have tuning into this and not having just watched the previous video on this, this is what we're doing. Because I'm in fact just continuing to talk straight after the previous one. I'm going to make sure everything is on the page. I hope people can read this. I'm going to have a bit more light on this one. So I'm just going to go through the source code that I have written so far in the Arduino IDE. I'm not going to put this on a website or anything because I kind of think it's better if you try and type it in yourself or if you try and work it out yourself. So I've set at the beginning of the code some constants. So I've used bytes here because I thought maybe it's a better idea to use bytes instead of ints. Because it's an 8-bit computer, so you should be using bytes. It seems fine. Like, none of these things, the actual speed difference matter. So this is the pin that I use. So I named the pin that I use for the reset to be 3, and the clock pin is 2. And then we've got the 2 enable pins, so enable 1, enable 2. So this is not written as to be completely general, it's just me writing some quick code to get it to work. So as we go through this and make it into a proper final game, then things will be a bit neater and tidier. And then I think I might publish the code. So we have this reset delay and a clock delay. I didn't actually end up using the clock delay. I'm not entirely sure I need to use the reset delay, but we'll see about that in a minute. So the setup code, pretty straightforward. All I'm doing is I'm setting the reset, the clock, the enable, and the enable 2 to be outputs, obviously, because that's what we're using them for. And we're just setting the reset to low and the clock to low just to start off with. Alright, and so we will go to the next page. So we have, the first thing we do before we get to the loop is this method, what are they called? Subroutines. We call them subroutines nowadays, don't we? Or do we? Functions. We'll just call it a function or a subroutine. Anyway, because I never know because different languages, I discussed this in the previous thing, different languages call them different things, and I'm a Java programmer so I want to call them methods, but I'm not going to. We'll call them functions. So this function here is set strip LED, I don't know if that's a really good name, and then I'm just passing in reference to the particular pins that I'm using, so this is trying to be general. So remember that I'm going to have 2 separate versions of this, one for each hand, so you're going to have to be playing twice at the same time. And so here we have the reset. So because we're going to have 2, they're probably going to have a complete set of their own ones for each side, because there's going to be 2 4017s. But I actually think you can get away with only having 3 extra ones, so we can probably share the reset between everything. So hopefully in the end I'm going to be controlling 32 LEDs from 7 pins. So that's a good start when you're using your I think I need more light. It just isn't showing up on the camera. It looks very moody. Oh, I am worried that this is not going to show up. So anyway, so those just passing those things. And the last one is the important thing, which is the position that I want to. So the whole point of this function is just simply to specify which LED I want to be on. And so the first thing I do is I set the enable pins to be low. So in my case, I'm using my transistor trick with an NPN transistor. And so by doing this, I am effectively momentarily turning off all the LEDs. And then I'm setting the clock pin to low just because I want to start off with it being low. It should actually always be low. I think I made it so that it goes back to being low at the end of everything, but maybe it doesn't. And then the reset pin is high. So when you set the reset pin to be high, it resets it back to pin 0. So the output, not pin 0, but the output is going to be on the first LED. And I just delay for a little bit just to make sure that the 4017 has a bit of time to do it. Though I don't think I need to do this at all. I think I can get away with doing some minor little instruction or something because it's very fast. It won't take very long. So this is probably I'm delaying far too much. I think I'm delaying 10 milliseconds, which is just too long. But it looks fine. It doesn't seem to have a problem with this. But later on, I think I will change that. And then we write the reset pin to be low again, so this allows it to go back to normal usage. So we've stopped resetting. If you have it high all the time, then you won't be able to use the clock because it will just continually reset. So we've given it enough time to actually reset, and now we've gone back to low. So we're all in a good state here. So this change bizarre int pause equals 1 is actually for me to waste a little bit of time, and I'll explain that as we come to it. And this one here, we have the result enable pin equals the enable 1. So by default, we're going to be enabling the first set of LEDs. And then down here, we've got if the position is greater than 9, so we're actually doing the second set, then we're going to subtract 10 from that position so that we're back to being between 0 and 9. So this is not generalizing, of course, to more than 20. And then we're going to actually set the result enable pin to be the second one. So if it's greater than 9, well, we're going to shift it back down so that we're within 0 to 10, but we're going to end up disabling the first lot, and we're going to enable the second one. So remember, when we start this off, both of them have been disabled. Right, so at the end of this, spoilers, we're actually going to re-enable whatever this variable says we should re-enable. So in this case, we start off, we're going to re-enable by default the pin of the first set, but then if we decide that we actually have to re-enable the second set, that's what we'll do. And then we're down to, right, I think we've missed out a, alright, here we go. This is the second one. Sorry, this is the second page from this thing here. So I dropped them on the floor and then I rearranged everything. And so then all we do is we go, looks like an exclamation mark for me upside down. So we go from I equals 0 up into, so we're just doing a little loop, and we're going to be going from 0 to whatever the position is. So if the position is 0, because remember we're starting from 0, we always count from 0 in these situations, then this loop will never actually happen. So we've reset it, we're back to the output 0, and if it actually the position that we want it to be is 0, then we never do this loop, and so we end up being the way that we want it to be. But if, say, it's 1, we'll go through here. So I've got this bit here where I pause for a little fraction of a second, and then I set the clock to be high, and then I do the same thing again, and we set the clock to be low. So this is me sending out a pulse, and the only reason that I've put some reasonably complicated expression in here is, even though when I did it without this, it was fine. You can actually clock it fine. The 4017 I did was fine, but when I read about these CMOS things running at 5 volts, they don't generally go up to 16 megahertz. So I'm not entirely sure. Like, I actually guess there's no point doing this now that I think about it, because this is a reasonably complicated function, because it's actually got to convert it to something different. So this is a pointless waste of time. But that was just me trying to slow things down a little bit so that you're not going to get the clock pin to go high and then the next 16 megahertz clock cycle you're going to set it to low, because that will be too fast for the 4017. But in fact, it will be quite a while before it actually goes back down to low. So the 4017 will register this as a little clock bump even without this. So I'm going to get rid of this now that I think about it, because it's pointless. But that's the whole point of it. It was just to try and slow things down, because this is just going to be me, the CPU doing some random stuff for a few seconds, a few nanoseconds or whatever it is, and then going on and setting it back to there. So we do this over and over again until we've got it clocked to where we want it to be. And then the last thing is we set whatever we stored in this result enable pin variable to high. So we enable the correct set. So that was, remember, just back here, set according to this. So if it was, by default, it's the first set, but if it turns out we want to do higher than 9, then it's going to be the second set. And then the last thing we have here, so this delay time is just me testing things, so this is just a variable that I can just quickly change. I feel like this is just not working because it's just not enough light. What do I point? Okay. I'm going to move it across a bit. I just remember the last time I did this, it was much better. But then I think when it comes out on the camera, it looks a lot clearer than it does now. So here is the loop part. So this is your standard Arduino loop function that you have. So we've done the setup one. So all this is doing, this is just test code. There's nothing particularly interesting about it. We're just going first from I equals 0 to 16. That's what this loop's doing here. So we're going through 16 times up until 16. Oh, actually, I must have put in, that's why it doesn't make sense. So we're going up until and including, so less than and equal to 16. So there must actually be 17 LEDs. So that's why my maths before didn't work out in the previous video, that no one would have noticed or understood what I was talking about. But so we're going to go from 0 to 16, and then all we're going to do is we're going to call this function that we just talked about, passing in these predefined constants and I. So we're just going to go through from 0 up until 16 step by step, and then we're going to delay for a delay time, which in this case here is 40 milliseconds. Not a very long time, but it makes it go backwards and forwards fast. So later on in our actual game, we're going to be doing something kind of similar, but the delay time will change as you keep hitting it, so that the ball will get faster and faster. So the lower this value is, the faster it will move. And then this one here just does the reverse. It just goes backwards. So this is a backwards for loop. The only difference here is that I'm starting at 15 because we've got, so when you finish this, you're on 16, and you don't want to do 16 twice because then it will pause a bit too long on 16. And so you start off at 15, and then you go down to 1, and this one will take care of 0 over here. And we're doing exactly the same thing, and then we're delaying again inside the loop. So this is the loop. So it's a bit hard to line everything up, but that's the loop, and that's the end of the function down the bottom. So I hope that makes sense as to how that part works. So this is the basics. So we're just working out if this was a game on a computer, we're just working out the display code for now. So the rest of the game is kind of like just boring coding stuff. Will be interesting coding stuff. What I mean is not going to make the best videos, but we will talk about a few other things, and I'm sure there'll be surprises. Especially when we think about how we're going to have two going at the same time, because I kind of do want to do it with only one reset pin, so we'll have to talk about that. So I'm just going to bring up these one last time, and hopefully you will be able to see. So that's the first page. I hope that shows up. It's all on 1080p, right? So you can see this on the screen. That's the second page. There. And that's this is the third page. That's right. So third page. Hopefully it focuses. I think that's the major concern. And this is the fourth page. It looks focused on the screen, but you can never tell. So yeah, thanks for watching, and like, share and subscribe, and hopefully we will be continuing with this project soon. I think the last part where I build the actual project and solder everything together and put it inside a little enclosure made of wood is probably going to take a while, and I won't be showing that on this channel, but I doubt I'll be showing it. I might show like a little bit of me putting it together, because it's just not going to be an exciting video, and I'm not that good at soldering, and I'm not very good at woodworking, so I don't want to make a video out of stuff that I'm not very good at. Not that I've done that so far. So thanks, like, share and subscribe, and catch you later.